Condenser or capacitor in its simplest form consists of two plates separated by an insulator called the dielectric. The condenser is able to hold an electric charge, then voltage is applied between its two plates. Ready? The initial charging current is high, but dropping gradually to zero until the condenser has built up its charge. As the charging source, the battery, is removed, the condenser should hold its charge indefinitely. In practice, a gradual loss of charge through leakage occurs. Then a conducting path is connected across the charged condenser, an immediate rush in discharge current occurs that would fall gradually to zero. By this process, the condenser acts as a temporary storage device. It may be shown that the electric charge held by the condenser is proportional to the applied voltage as Q is equal to CV, or Q is equal to C is equal to Q over V, where Q is the quantity of electricity in coulomb, V is the applied voltage in volts, and C is the capacitance value in farad. This unit is suggested by a scientist by name farad. The unit value of capacitance is too large, and hence in practice submultiples are generally in usage. 10 power minus 6 farad is 1 microfarad, and 10 power minus 12 farad is 1 picofarad. When condensers are connected in parallel, the total value of capacitance is the sum of their individual capacitances. C is equal to C1 plus C2, etc. When condensers are connected in series, the reciprocal of the resultant value of condensers is the sum of the reciprocals of individual condensers. 1 over C is equal to 1 over C1 plus 1 over C2, etc. The time for C to get fully charged would be infinite. In other words, the current never quite reaches zero, although it comes very close to zero after a short period. In order to make a convenient measure of the time taken to discharge, we adopt the time constant. This is the time taken to discharge the condenser to the point where the voltage or charge drops to 1 over epsilon, or 36.8% of its initial voltage. T is equal to CR, where T is in seconds, C is in microfarad, and R will be in megohms. The same applies also to the time taken by the condenser in its process being charged to reach a voltage or charge of 1 minus 1 over epsilon or 63.2% of its final value. The time constant is equal to T is equal to RC. Under the environment, that vacuum tube groups practically disappeared. A family of new generation of capacitors are largely produced and used in printed circuit boards. Earlier, several solid dielectrics such as paper, plastic, glass, mica and ceramic capacitors were produced with a view to meet high voltage applications. This situation has changed dramatically with the advent of solid-state devices and circuits who now put in a huge demand of low voltage, small size capacitors. Polyester, polystyrene, polypropylene capacitors replace earlier version in the range 1000 pf to 0.1 microfarad with working voltage of the order of hundreds of volts. This group offers better stability and aging performance. Ceramic capacitors brought in revolution that are generally small, economical, and useful for high frequency applications. They are extremely tiny, allowing them to be soldered directly onto the printed circuit boards. These miniature disc type ceramics appear in different formats: ceramic disc, silver ceramic arms, multi-layer ceramic, ceramic chip, multi-layer chip, ceramic, etc. Other new generation capacitors include high voltage ceramic, polypropylene, metallized film type, tantalum ceramic, both disc and multi-layer, hermetically sealed tantalum polymer, chip capacitors, etc. Turning to electrolytic capacitors, the new generation includes conventional electrolytic types, long-life polymer capacitors, tantalum small-size capacitors, and so on. This new range miniature electrolytic capacitors of low working voltage replace earlier conventional disc size axial lead capacitors. With space consideration and printed circuit format, vertical mounting of components is preferred. Hence, most of miniature capacitors, including electrolytic types, are of radial lead types, enabling vertical mounting in the board.